Okay, so far we have looked at some rather, I don't know if difficult, maybe challenging, maybe new, maybe that's a good way of describing it, but just some new examples that have been rather difficult when it comes to thinking about limits. The nice thing is, if we know that the question is talking about a continuous function, so especially at the x value that we're interested in, if we know that it's continuous, we are allowed to just simply plug in the x value that we're looking at into the function, and that's going to be the limit. So a good chunk of your homework is going to be like this. I think the first several questions that I ask, it's just a matter of plugging in the x value, but you have to know it's continuous. So we kind of have a working definition of continuous right now. We're going to figure out later on a better way of defining continuity using some limit ideas, but now we're still just basing it on that informal definition of something's continuous if you can trace it from left to right without picking up your pencil. So just a few quick examples. If we are looking at negative x squared plus 1, that's a parabola, so we know it's always continuous. We are allowed to simply plug in the 1. If we're looking at the limit as x approaches 1, we can just plug that 1 right into the function. So for the first one, we could write something like we're taking negative 1 squared. We're going to add 1 to it. So that's the general idea, I guess. And when we do that, we end up with negative 1 plus a 1, which is 0. So you could think about what this particular function would look like, what it's doing. You could probably even think of a pretty realistic graph and show that that matches up. In part B, we are plugging a 3 in, and this one's a little bit more complicated. We have the square root idea, but that's going to have issues when x is negative 1 or less based on this function. And then our denominator, we have an issue at 4. So even though we have some issues with it, at 3 and around 3, it's going to be continuous. So because of that, we are simply allowed to plug that 3 in. So we would have, here, let me kind of break that up a little bit. We'd have the square root of 3 plus 1 all over 3 minus 4. Okay, so we'd have square root of 4 over negative 1. And in the end, that's just going to get me, square root of 4 is 2, so I'm going to have negative 2 as my answer. Okay, in part C, we're just using slightly different notation. Instead of an x, we're using h, but it will still work out the same way. There's no issue, even though we're looking at h approaching 0, and a lot of times zeros could cause some issues. In this case, it's not a big deal at all. And if we think of the function here, that's just a polynomial. Polynomials are always continuous. So for part C, we'd have 3 times 0 squared plus a 2 times a 0, and that's just going to get you an answer of 0. And then in part D, this one is a little bit more confusing because there's just a couple variables here. This kind of gets away from thinking about it like a function, so we'd have to maybe just be okay with something being a little bit different here. But we have 3x squared minus 2xh plus 5h, and we're saying what's the limit as h approaches 0. So we just kind of, in some ways, ignore the x's and say we're just going to make the h 0, and it sure looks like we would get an answer yet. So a little bit of a different thing. This will mean something special and unique down the road. But for this, I'd have 3x squared minus 2x times, instead of h times a 0, and then plus 5 instead of h times a 0. And as I go through that, basically the last two chunks are just going to go away because we're multiplying by 0, and I'm just left with 3x squared. Okay, and then just one other quick thing. We have a lot of just kind of summarizing rules when we know that a function is continuous and we want to, maybe we know some limit ideas that a problem is telling us, and we need to somehow combine it with other ideas. I think basically here, just use common sense. You can certainly look at the rules a little bit more in depth, but in general, just use common sense. So we're going to look at we're going to look at these examples right here. What they're telling us up right here is that we're looking at as x approaches c. So c is a certain x value. We're approaching that value, and function f gets really close to 2 there, and function g gets really close to 3. And if you notice, all of the examples that we're always getting close to that x value of c, wherever that is on a graph. So again, just use common sense. If we're gonna, in part A, say what's the limit as we approach C of 5 times g of x, what we're gonna do is say, well, just take 5 times the limit idea for function g there, which was 3. So 5 times 3 gets me 15. It's as simple as that. In part B, it says, again, the limit as x approaches c, so we're in the same area for all of these. But now we're going to take function f plus function g. So we take the two values that they gave us, 2 and 3, we just add them together and we get 5. In part C, it is function f times function g. And again, we're getting close to the same x value of c, so we're just going to take 2 times 3 and we get 6. And for part D, it's function f divided by function g now, so we would just divide, and that would be 2 over 3, and that should be our answer there. So every now and then there's just some problems like this that just test, do we understand general properties? I think what would be good is just to maybe clarify this a little bit more in class, just to give you a couple of visual ideas of what this might represent. But we'll call that good for now.